Page 132, Work, Force, and Motion. Recap, Section A. Motion refers to a change in position of an object in relation to a fixed reference point. Speed, velocity, and acceleration describe the motion of moving objects. Speed is the change in position of an object during a certain unit of time. Average speed is calculated by dividing distance by time. Velocity describes both the speed and the direction of the motion of an object. Velocity is reported in meters per second in a specific direction, such as north, south, east, or west. Acceleration is the change in velocity per unit of time. The velocity of an accelerating object will change each second. For example, an object with acceleration of 2 meters per second squared will increase its velocity by 2 meters per second every second. An object moving with constant velocity, both speed and direction, are constant and have no acceleration. Objects which are moving in a circular motion are constantly accelerating due to a continuous change in velocity. Specifically, their direction is changing. The speed of the object may be constant when they go in a circle, but the direction of motion changes continuously. Thus, the velocity is changing. Section B. A force is a push or a pull. All forces are measured in newtons. A newton is the amount of force needed to accelerate a mass of 1 kilogram, 1 meter per second, so 1 meter per second squared. When the forces of an object are balanced, there is no change in motion. Balanced forces do not cause a moving object to stop moving, and they do not cause a non-moving object to start moving. For example, the book on the table to the right will not move because the forces are equal. The force of gravity pulling down on the book is equal to the force of the table pushing up on the book. So this is an example of balanced forces. Unbalanced forces on an object produce a change in speed or direction of motion. For instance, if a person lifts the book off the table, the lifting force is greater than the force of gravity on the book, and the book will move. Its motion is changed by the unbalanced forces. Friction is a force that opposes the motion between two surfaces that are in contact. All surfaces have irregularities. The rougher the surfaces which are in contact with one another during movement, the greater the force of friction between them. Lubricants, such as oils, generally decrease friction because they fill in irregularities and form a smoother surface. As the weight or other force acting on objects in contact increases, the friction between them also increases. So the weight of an object does affect friction. Gravity is the force of attraction between two objects. The universal law of gravitation states that the force of gravity between objects depends on their masses and the distance between them. As distance increases, so as two things get further from one another, the force of gravity between them decreases. An object with greater mass has more gravitational force than an object with a lower mass. All objects have a gravitational force, but the force is only noticeable in objects with very large masses, such as the Earth and the Moon. So for example, if you compare the mass of the Moon and the mass of the Sun, since it has a larger mass, is going to have a greater gravitational force on the Earth because it has a larger mass. Weight is a measure of the force of gravity acting on the mass of an object and is measured in newtons. Mass is the amount of matter in something and is measured in grams or kilograms. The weight of an object varies depending on the force of gravity pulling on the object at a given location. The mass of an object does not change with location. For example, An object with a 100-gram mass weighs about 1 Newton on Earth. As the object is taken farther and farther from the Earth, the object's weight will continue to decrease, but its mass will remain constant at 100 grams. Another example is your mass both here on Earth and on the Moon would be the same. However, your weight would change between the two locations, which is why when we see pictures of people walking on the Moon that they seem like they're floating. It's because they have less gravity on the Moon. Section C. The relationship between force and the motion of an object is explained by the laws of motion, stated by Sir Isaac Newton. Newton's first law, also called the law of inertia, states that every object continues in a state of rest or keeps moving in a straight line at a constant speed unless it is acted on by an unbalanced force. Newton's second law states that the force equals mass times acceleration, or F equals m times a. In other words, the acceleration of an object increases as the force exerted on the object increases. Also, when the same force is used to move two objects with different masses, the result will be a greater acceleration of the smaller mass. Newton's third law says that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Section D. Work. Work is done when an object is moved through a distance in the same direction as the applied force. For example, lifting a box from the floor is work because the upward lifting force causes the box to move upward. Carrying the box across the floor is not work because the upward force against gravity on the box when it is carried is not in the same direction as the forward motion of the person in the box. So in summary, the direction has to be the same as the force for it to be considered work. Work is calculated using the formula W equals F times D, or work equals force times distance. The unit of force is the Newton, and the unit of distance is the meter. Work is reported in Newton meters, or Nm, or it can also be recorded as joules, which is a capital J. Power refers to the rate at which work is done. The formula for calculating power is work divided by time. So P equals W divided by T. Power equals work divided by time. Power is measured in watts, which is a capital W. Section E. Machines are designed to make work easier to perform. They do not decrease the amount of work. That's a huge concept. Machines make work easier. They do not decrease the amount of work. Simple machines have few or no moving parts, and the work is done with one basic motion. The force applied to the machine by the user is called the effort force. The force applied to the machine to overcome the resistance or weight of the object is called the resistance force. Simple machines make work seem easier by 1. Decreasing the amount of effort force needed to do the work. 2. Changing the direction of the effort force. 3. Changing the distance through which the effort force is applied. And or 4. Changing the speed at which the resistance moves. The mechanical advantage, or MA, of a machine indicates the number of times the machine multiplies the effort force. Mechanical advantage is calculated by dividing the resistance force by the effort force. Efficiency is a measure of how much of the work put into a machine, work input, is changed into useful work put out by the machine, or work output. Efficiency is a percentage that is calculated by dividing the work output by the work input and multiplying it by 100. When you multiply it by 100, that means it's going to become a percentage. A machine never has an efficiency of 100%. The work input is always greater than the work output because some of the work is lost due to friction and transferred into thermal energy. The efficiency of a machine can can be increased by lubricating the moving parts of a machine to reduce friction. There are 6 basic kinds of simple machines: the inclined plane, lever, pulley, wheel and axle, wedge, and screw. The wedge and screw are variations of the inclined plane. Compound machines are made up of a combination of 2 or more simple machines. A pair of scissors and a bicycle are examples of compound machines. This concludes the work, force, and motion section.